Hello, Brandon Clayton here, the Algebra Guy, simplifying expressions with the laws of exponents. We're going to continue talking about part 2, but this time we want to talk about quotient properties and zero and negative exponents. So the TEK is still the same, but there's a couple of pieces to it that we have to include. So I'll make this second video. Now, I want to remind you that these properties are on your reference sheet again. So I said this earlier, but please continue to remember that all these are here. So if you forget the rules, you can just refer back to there. All right, so let's get to it. Up to this point in the course, we've developed the properties for exponents for multiplication. We talked about the product rule, the power rule, and such. Now we're going to look at division. So what if I had x to the fifth divided by x squared? What you're really saying is I have 5 x's multiplied by each other and 2 multiplied on the bottom. Well, remember that we can just cancel those x's out. So these x's cancel out to 1, these x's cancel out to 1. Now I just have 3 x's. Well, x times x is just x cubed. So in other words, x to the fifth over x squared is the same thing as saying x to the fifth minus 2. So that gives us x cubed. Same thing here. What if you have x squared and x cubed? Well, we have 2 x's on top, 3 on the bottom. We cancel out 2 and we're left with 1 on the bottom, so that's 1 over x. In other words, we could have just said this is 1 over x cubed minus 2. 3 minus 2 is 1 on the bottom, so that's 1 over x. Here are the two properties that we're going to work with here for these first few problems. If you have a to the m over a to the n, you're going to subtract those, m minus n. If the m, the number on top, the numerator exponent, is greater, we're going to say m minus n. Now, if the n is greater, the numerator on the bottom is greater, we're going to put a 1 on top and say n minus m. I'll show you in just a second. As a matter of fact, there's a faster way to do this one, but it's nice to know this way as well. So here's an example. 4 3/4 over 3 squared. The bases are the same, so I can subtract these exponents going 3 to the 4th minus 2. 4 minus 2 is 2, so 3 squared is 9. What if you have the bottom number is bigger? Well, you can just put 1 over 5 to the 3rd and then subtract the 2 from the top, which gives us 1 over 5 to the 1 power, which is 1 over 5th. All right, so let's do a few practice problems. So this is going to be the same thing as saying x to the 10th power minus 8, because we're going to subtract the exponents, 10 minus 8, which is going to give us x squared. Here, the same thing, 2 to the 9th over 2 squared is 2 to the 9th minus 2, which is 2 to the 7th. In this situation, we have the denominator has a larger exponent. So we're going to say 1 over b to the 15th, which is since it's already here, minus 10, which is going to equal 1 over b to the 5th. Same thing, the denominator is larger here, so we're going to say 1 over 3 to the 5th minus the 3, that's the exponent on the numerator, so that gives us 1 and 3 squared. On this problem here, we have the same situation where the denominator's exponent is bigger, so we say 1 over a to the 9th and minus 5, which is 1 over a, that's an a, not a 9, a to the 9 minus 5, which is 4. And the denominator here is, the numerator's exponent is bigger, so I can just simply say x to the 11th minus 7 is 11 minus 7 is 4. And there you go. So that's how you would simplify these expressions. Now we do have a special case. What if you have the same number divided by the same number? Well, you've already learned that any number divided by itself is 1. But what does that look like when dealing with exponents? Well, think about it. What you're really looking at is saying you have some number to the 0 power, or let's say you had 2 to the 3rd. Let's make up one. 2 to the 3rd divided by 2 to the 3rd. Well, if I use my properties that we just discussed for quotient rule, we'll do 3 minus 3. Well, 3 minus 3 is 0. So 2 to the 0 is equal to what? Well, I know what the answer is because anything divided by itself is 1. So 3 minus 3 is giving me 0. 2 to the 0. So 2 to the 0 must equal 1. As a matter of fact, 3/4 divided by 3/4 Well, that's going to be 4 minus 4, so that's 3 to the 0. So this is all equal to 1. So what we're learning is that anything to the 0 power is equal to 1. I love that property because knowing that properly simplifies so many expressions. And I've seen even on SAT tests where they'll put a 0 there in this long convoluted problem to see if you know that rule and you can apply it. So let's practice it. So 12 to the 0 is good. 1 y to the 0 1. All of this 7z to the 0 still 1. All of this, look, I don't even have to matter what this is because all this parentheses is to the 0 power. That's just 1. What about this one? Well, I can't do this whole thing, but I know that this piece is going to 1. This is times 1. And I'm going to leave all of this the same. So my answer is just going to be negative 3x squared times 1, which is just negative 3x squared. So there's how you do those to the 0. All right, quotient to a power property. What if I take a quotient problem to a power? So it's just like what we did when we took the product to a power. Let's look and see. To raise a fraction to a power, we raise the numerator and the denominator to that power, just like we've done before. Here's an example. So 2/3 cubed. Well, all we're doing is taking this 2 to the 3rd power and a 3 to the 3rd power, and we're solving it. So it's just that simple. Let's do that now. So in this case, we use our product to, well, it's the power property here because we're going to go 2 times 3. Well, 2 times 3 is x to the 6th because we multiply these according to the property we learned in the last video, and that's going to be over x to the 5th. Well, now I have a quotient situation where I have the same base. So what can I do with the exponents? Well, this is bigger on top, so it's just going to be 6 minus 5. 6 minus 5 is just going to give me x to the 1, or actually just x because we usually don't write a 1 there. All right, so rewriting this one, this is m to the 8th, and I multiply these two according to what I've learned in the last video. 4 times 2 is m to the 8th. Well, what do I do for a quotient property? Well, you subtract the exponents of a like basis. So 8 minus 8 is m to the 0, m to the 0 power. M to the 0 power, we learn anything to the 0 power is 1. All right, what is this up here? So all of this is squared. So that means I'm taking x to the 7th and squaring it. I'm using the power property there. And I'm taking x cubed here and squaring it. So it applies the same way. So 7 times 2 gives me a 14. And 3 times 2 gives me 6. Now I use my quotient product that says when you have the same base, you subtract the exponents. So this is 14 minus 6 is 8. And let's continue going. Same rules. Multiplying these two will give me a 6. And 5 to the 3rd power, that's 5 times 3, which is 15. So I skipped a step there by just doing it right here in my head because we've done a few of those. So 5 times 3, 2 times 3. And now what do I do here? Well, the bottom is bigger, so it's going to be 1 over p. Because there's more p's on the bottom, you can imagine there's not going to be anything left when you cancel out. So this is going to be 15 minus 6, which is what? 1, 6, 8, 9. So p to the 9th power. All right, what about all of this to the 4th power? Well, I need to raise every single piece to the 4th power. So this is going to be 2 to the 4th. X cubed to the 4th, 3 to the 4th, and y to the 4th. So don't forget to apply that to every single factor in that parentheses. Now we can simplify. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I feel like I want to change colors. There's a lot of blue. 16. 3 times 4 is 12, so this gives me x to the 12th. 3/4 to the 4th, I believe, is 81. 3 times 3 is 9. 9 times 3 is 27. So this is 81. We have x. Nope, no x is on the bottom. We just have y to the 4th. All right, so can we simplify anything? Like, so there's no x's, no variables are going to simplify because we got x and y. They're different. But can we simplify this? Well, neither one of them are even. So I know we can't divide by 2. And we have a 4. That's not going to work here. So I think that's just going to stay that way. But if it could simplify, and often it does, you want to go ahead and simplify those. All right, so let's do this one. let's start by doing our power rule. Y to the 6th power and y to the 8th power divided by y to the what? 20th power. All right, so I know from my previous rules that when I multiply like bases, I can do what to the exponent? I can add them. Good. And divide by y to the 20th. And that leaves me with what? So I know my exponent on the bottom is bigger, so it's going to be y to the 20 minus 14. 20 minus 14 is y to the 6. And that's it. All right, keeping it going. What if I have this right here? How do I handle it? So I just square, in this case, I'm just going to square the top and square the bottom, which is going to give me 25 over 64. And same thing here, x to the 4th over 3 to the 4th. And simplifying it a little further is 3 to the 4th will give me 81. I know that looks like a 34. I should have made it a little bit smaller. So 3 to the little bitty 4. Okay. Y to the 3rd power, because it's y, the 3rd goes to the y and it goes to this m. And voila. Those are our answers. All right, so we've now seen all the property of exponents. We'll use them to divide monomials later. So this is going to come up later. So later you'll use them to divide polynomials. Find the quotient to the following expressions here. So the first one is this one. I'm going to rewrite this one, right, so that it can look like we're used to. Divided by 7x squared. So this becomes easy to see that 56 divided by 7 can give me an 8. And I'm having the like bases that are being divided, so I can subtract the exponents. 5 minus 2 gives me an x to the 3rd. And right here, I have 42 divided by negative 7 will give me a negative 6. Actually, let me go ahead and draw a line so you can see what's going on. And I could put a 1 there, but it's not necessary. X squared over x, well, that's x squared over x. I'm going to subtract my exponent, so this becomes x squared minus, let me write this out. So this becomes x squared minus 1. So x squared minus 1 is just x. So I did the 42, took care of my x's, and I have a bigger number on top here. So I know it's going to be 1 over something. Now I don't have to write 1 because I already have some stuff up here, and writing 1 is not going to change anything on the numerator. But I know on the bottom I'm going to have y 5 minus 3, which is 2. So that's all I'm left with here. I should have drew a smaller line. 24 over 48 can simplify to 1 over 2 because 24 is half of 48. A's to the 5th and A's 1. Well, that's just subtracting 5 minus 1 is 4. So this would be A to the 4th. And so deal with that one. Got that one. And B third to the B 4th. Well, the bottom is exponent is bigger. So I know we're just going to be left with the 1 on top and 4 minus 3. So 4 minus 3 is just 1. So that's going to be a B, not an A. So that's a B there. So you're not going to see a 1 there. You'll see A to the 4th divided by 2B. All right, same thing here, 14 over 21. These can both be simplified by dividing by 7. 14 divided by 7 gives me a 2. And 21 divided by 7 gives me a 3. X to the 7th and x to 11. I got a bigger number on bottom, so it's going to be 11 minus 7. 11 minus 7 leaves me a x to the 4th. And a bigger number on top, so I'm still going to have a y value up top. 12 minus 6 is 6. And that's it. All right, look at this guy here. So what if you have a problem like this where you have a product and expressions and all these things going on? So first thing we're going to do is find the product of the top. So we have a product problem and a quotient problem at the same time. Let's go ahead and take care of the product here on the top. So I'm going to multiply my 3 and 10 because they're all being multiplied. So this is 30. I'm going to cross those out so I don't forget. X cubed times x squared. add the exponents gives me an x to the 5th. Y squared times y to the 3rd is y to the 5th. Notice these don't take very long, and you don't need a calculator for most of them unless you get really big numbers or something. But they can go by pretty quickly once you get the rules. And on the bottom, I'm just going to rewrite what I already have. Can I simplify anything from this point? I sure can. 30 divided by 6 is 5. So that leaves me with a 5. X to the 5th of x to the 4th. Well, that's subtracting because we're dividing. And the exponent is bigger on top. So that's just going to be x, because 5 minus 4 is just 1. So we took care of those. And 5 minus 5 is 0. There's nothing there. So anything to the 0 power is 1. So no need to write anything else because it's still going to be 5x. All right, so we talked before about what if the exponent on the bottom is bigger. You keep hearing me say that. Well, I want to introduce another idea. What if we just subtracted those two numbers? Instead of saying 1 over 5 minus 2, what if we just said 2 minus 5? Well, if we just did, in this case, 2 minus 5, that would give us x to the negative 3. What is that all about? What is x to the negative 3? Well, we already know how to work this, and if we work it out, we've found that we'll do x to the 5th minus 2, which gives us 1 over x to the 3rd. So we learned that x to the negative 3 is actually the same thing as 1 over x to the 3rd. So this gives us an introduction into negative exponents. We've already been doing them, we just haven't called them a negative exponent. So when I subtract 2 minus 5, from using my quotient rule, we get a negative 3, and that's actually been giving us 1 over x cubed. So now you know how to operate with a negative exponent, even though we haven't formally introduced it. So here's how it looks. Anytime you have a number or expression or term raised to the negative exponent, all you're going to do is write 1 divided by that same number or term to that exponent, but in a positive. And this will go both ways. If it were in the denominator, let's say if it was like this, a to the, let me do a to the negative 1, and I wanted to get that negative exponent gone, I could bring it up to the numerator. So anytime it goes from the numerator to the denominator or the denominator to the numerator, it's going to go change that sign from negative to positive. But we'll work some problems to see that. So I just explained this. Here's the wording if you want to pause it and read it. All right, so let's work a few of these. 4 to the negative 2. Well, we just learned that that's the same thing as saying 1 over 4 squared. Well, 1 over 4 squared is just 1 over 16. What's the temptation when you see negative 2? The temptation is to think that it's going to be a negative answer because we're used to that. We got multiplication with these exponents and we want to say negative something. But in actuality, we just learned that anything to the negative power, we're just going to do the reciprocal of what we normally would do. In this case, it would be normally 4 squared, but now it's 1 over 4 squared. All right, same thing for this one. This is going to be 1 over 10 cubed. Well, 1 over 10 cubed is 1 over 10 times 10 times 10. Which is 1 over 1,000. Rewriting this one is going to be 1 over this whole thing squared. Well, what's 1 over all that squared? Well, that's negative 3 times negative 3, which is a positive 9. And you try to do this next one. Looks a little bit tricky, doesn't it? We talked about this one. Pause it here. All right, so I would remember that this negative is going to stay there. So this negative in this sense is not necessarily attached to this 3 like it is here. So this is still going to be 1 over 3 squared, but this whole thing is still negative. Because that negative just is not connected to this negative. It's not negative 3, negative 3. It's just a negative sitting out there by itself because it's not in the parentheses. So this is actually going to give me negative 1 over 9. So that parentheses makes a big difference. Here is going to be 4 times 1 over 2. Because normally it would be 2 to the 1, which is 2, but now we're going to do 1 over 2. Well, what is 4 times a half? Well, that's just 2. And here we end up with 1 over 4 times 2. Notice I just rewrite the whole thing just the way it is, so there's no confusion. I just take this whole piece and we're going to put 1 over that to the 1 power. So now that's the positive power. 1 over 4 times 2 becomes easy to see that it's 1 over 8. All right, you practice this one. Pause it here and see if you can work through these. All right, x to the negative 6 is the same thing as 1 over x to the 6. This is going to be 5 over y. Remember that negative 1 is not, so this is not in parentheses. I want to draw this so you don't get confused. There's a difference between that and what we just did. This parentheses is saying the negative 1 is applied to the 5 and y, but it actual is just the y for this particular problem. This one is applied to the whole thing. So now I'm going to take this whole piece, 5y, and it has to be to the negative 1. So this whole thing is to the first power here. And it'll just look just like that without the parentheses. What about this one here? So same thing, all of this negative 5y. So because this whole piece is raised to the 1 power. All right, let's bring it all together, simplify these expressions here. Multiplying these, we have the same base, so we add the exponents. I want you to pause it, work through these yourself because we've covered everything at this point, and you should be able to do this one. All right, so we get, when we add these, we get x squared. We can add these again. We get y to the negative 2. So even though it's a negative exponent, we're still going to apply that same rule. We can add these here, z to the negative 8. All right, applying our same rules, we got m to the, or actually I don't have to, yeah, we'll do that. M fourth times negative 5th, so the m's have the same base, so we can add the exponents. 4 plus a negative 5 is a negative 1. And same basis, negative 3 plus negative 5 is a negative, negative 2 is a negative 5. Now we don't simplify expressions with a negative exponent, so this is not going to cut it. This is not going to fly. You're not going to see the answer choice often on a test because they want it in positive exponents. So we remember our rules that anything to the negative 1 power is the same thing as the reciprocal, and you taking off that negative. So now we have 1 over m because this is to the 1 power. We don't have to write a 1 there, so it's the same thing. And this is 1 over n to the 5th. And we already have a 1 there, so this is what it's going to look like rather. All right, what about this one here? So again, we're going to use all our rules. 2 times negative 5 is negative 10. So took care of those. So we're going to multiply x to the negative 6 and x to the 5th. We're going to add our exponents to be x to the negative 1. And we know that's going to change here in a second, but we'll just keep it the way it is right now. 8 plus a negative 3, because we have like bases, we add those exponents to get y to the 5th. So what is this going to look like? So I have a negative 10. Let me write a line here. So I have a negative 10 up top. This x is going to go below because it's reciprocal, because that exponent is negative, and y to the 5th stays above because it has a positive exponent. Nothing changes there. All right, what about this one? We do the power rule. 3 times negative 2 is a negative 6, which is the same thing as 1 over k to the positive 6, because we always want to keep it in positive exponents. 5, everything in here gets squared, so this 5 gets squared to 25. The negative 3 gets multiplied to the negative 2, which is x to the negative 6. And I can rewrite this as 25, and this x to the negative 6 now is reciprocated with a positive exponent to be 25x to the positive 6. What if I have a negative in the bottom and I want to make it positive? Well, remember, we can just bring that to the top. So this becomes r 5th times r to the positive 4. So this, if you bring this up to the top, now it changes that from negative to positive. So anytime you move this whole entity to the denominator, it's going to change it to negative, or it's going to change the sign, I should say. In this case, it changed it to a positive. So now we can add our exponents because we have like basis to r to the ninth power. All right, what does it look like on a star test? So here's a problem that we came across. So we got these two numbers. We can simplify 14 over 8. They both divide by 2. So 14 divided by 2 is 7. So let me draw this line here. And I have 8 divided by 2 is 4. So I already got that piece. No other numbers in here, so I know those should be my numbers. So I'm going to glance over here. 7 over 4. Yep, that looks good. This is a possible answer. It can't be this one because it's not a 6, but it could be the others. All right, let's keep working. So we dealt with that. Let's deal with our A. Now when we're dividing like bases, what do we do with the exponent? Well, don't be confused by the negatives and just remember the rule. I'm going to take a to the 4th minus -2. So 4 minus -2, what is that going to equal? Well, 4 minus -2 is the same thing as a plus 2, which is a to the 6. So that's a to the positive 6, so that goes up top. So now I have this next one, b to the 6, and I'm going to subtract 3 because we're looking for the quotient, and that's going to equal 6 minus 3, which is b to the 3rd. And this one, c to the -10 minus a -5. Notice I'm doing minus a -5. Again, a lot of students will just say -5, but this is minus a -5. And that is going to give me -10 plus c. Let me write that, -10 plus 5. Well, what's -10 plus 5? C to the -5. So that's a negative number. So I know that number is going to go to the bottom to get it to be positive. So because we can't have a negative exponent. So c to the positive 5th. So that is what I'm looking for. So let's see if we can find that. A to the 6, 4. Yep, this looks good right here. I just forgot to put my 3 here. 3. There we go. So 7a6, b 3rd, 4c to the 5th. H is our right answer for that one. All right, let's try this one. Pause this one, see if you can get the right answer by yourself. All right, so we're going to do it the same way we did a second ago. 12 divided by 3 can be simplified to just 4. I have no other numbers I'm dividing, so I know it's going to be a 4 here. So I glance over here just real quickly. I see a 9. No, it's not going to be a 9 here. Not going to be a 9. So I know it's between B and D. Just from that, if I ran out of time, I can be like, oh, I only have 2 options. There are. So what is x to the 6 minus 2? So we can subtract the exponents here, and that gives me x to the 4th. That's positive, so I know it's going to stay up top. X to the 4th. So I got my x's, and y to the 4th, y to the -4th, minus a -6, minus a -6. So there's a lot of minuses and negatives going on there. So how can I rewrite this? This is -4 plus 6. What is -4 plus 6? That is a positive 2. So I know that's positive, so it stays up top. And lastly, z, we usually draw a z with this little line, so you differentiate it from the 2. So that's z squared, minus the 3, because that's 2 minus 3. We subtract our exponents, numerator from denominator. So we can always do numerator minus denominator now. Now that we learn that we can deal with the negatives, we're okay with that. We can always say numerator minus denominator, which is what you see I'm doing here. So z, 2 minus 3 is going to give us a -1. So to get that negative to go away, I'm going to take it from the top to the bottom to be just z to the 1. Don't have to write a 1 there. Which answer has this? This looks good. Yep. This is the one we want. Hey, that does it, guys. Thanks for tuning in. We just learned all the rules covering exponents, power rule, product rule, quotient rule, 0 to the 0 power, to the negative power. Congratulations. That's everything concerning simplifying rules with exponents. My name is Clayton, the Algebra Guy, and I will see you next lesson.